Thanks, Patrick. Thanks for having me. It's really exciting to be here. So, I am not a poet. I just happen to be lucky and I'm good at math. So, this phrase, collecting and managing high-volume real-time telemetry data from a distributed network. What is that? Well, put it another way. The thrilling story of a small team tasked to design, build, and maintain a novel computer system all over the fly. And yes, it's cheesy. No, I didn't really pitch this, but what I'd like to talk about today is kind of the learning lessons and trials and tribulations, if you will, as our team went through while trying to stand up our first analytic system in general, let alone time series tool, while developing our.
Can you guys look here? I know the fans
No,
are a
mic.
little bit loud.
Better have mic. You can mic that.
Sorry, my throat is a little dry today.
Can I get you some water?
I can actually.
Okay.
So yeah, name's Patrick Curtis and I lead the data science team. Is that good?
Yeah.
Awesome. At Storage Labs, based out of Atlanta, Georgia, and I've been with Storage since September of 2016, which is to me kind of crazy because in 3.5 years, well, in startup years, is a lifetime. When I joined, for some context, we were building something what we now call the V2 network. And, well, it was great. We put it out into the wild, but then we realized that it had some scaling problems. And that was a vast oversimplification of a lot of different things in the past, but we can go to our white paper afterwards and we can talk about what those problems were. But nonetheless, the reason it's called V2 is because currently we have a V3. We made the decision to, from scratch, the V2 version was written in Node.js and used a MongoDB backend and some other things to say, no, we're not going to continue to patch that, we're going to do it in Go, we're going to do it from the beginning. So what I'm about to go through the next several slides and what I'd like this talk to be about is a high-level overview of not the development process in general, because, well, I pretend to be a software engineer, but I am a data scientist at heart, and I'm sure there are at Storage much more qualified people to talk about that. But what I like to talk about is like during the engineering development process, the data needs that came up and the systems that we had to build to meet those needs. Essentially, there's a cliche, right? Startups. It's building a rocket, well, on a rocket, right? Cliche, but true in many times. So, if you have a network, and I'll get into the overview of the details of the network in a bit, that is highly predicated on some dynamic systems working that are data-driven, but you don't have data yet, right? Like the cold start problem. Well, it's very important that the second you have an MVP of whatever type, that you start generating information very quickly so you can fix it before you turn the situation. So that's what this is going to be about. I'm hoping that at the very least you'll find some. Actually, let me ask you a question of the people here who have experience using InfluxDB. Okay, so that's awesome. I would like to talk to you afterwards. So, okay, hopefully there are some interesting takeaways here, because I will be the first to admit that when it comes to Influx, I am not an expert. My first use of Influx was about 9 months ago, and, well, 9 months is not enough time to master anything, especially with something complex like this. So, without further ado, let's dive into it. So, again, I'm going to assume that y'all don't know about storage. One day maybe it will be a household name. But what storage is the network, the protocol, as opposed to the company itself, is decentralized cloud storage network. What does that mean? So cloud storage, everybody familiar with that? Amazon S3 would be like kind of the prototypical example of pinnacle. The cloud, as I'm sure you all know, is a giant data warehouse sitting somewhere, well, on the West Coast, I don't know where it would be, but I know where I am in Atlanta, somewhere in Virginia. Millions and millions of racks, and that's great. Amazon has proven that that is a awesome model. It makes money. It's extremely useful. I've used it. I'm not going to speak ill about it. But it does have its downsides, right? One of which is potentially, reasonable people can disagree, security, and would probably make it better or more optimal if you were really smart about it if you decided to decentralize it. I know given the past year or two, decentralized has a lot of different meanings, Bitcoin, Ethereum, but what we mean by decentralized is quite literally verbatim the word, instead of having your data in a central location, have it in several locations. So what you see here, and these are our names for these different services, they're not actually satellites, but the three high-level components of what our satellites are, well actually let me start here, are stored nodes because they are the backbone of our network. Imagine if, right, that warehouse I was talking about in Virginia, if you took each blade out of a rack and put it in a different part of the world, but instead of just being owned by Amazon or another company, it's owned by an individual, a person who either is an aficionado of distributed systems or really likes being part of kind of a change in the paradigm, running our software, either sometimes actually in their home. I have one set up in my home, a Raspberry Pi, or through some other mechanism. We don't own that. They do, right? But we store information there on behalf of our customers, clients, or their applications, and the code base and the tool sets that customers use to upload information, and we call them uploads. Now, we could do a whole separate talk, like diving into the particulars of this, what it means to be an uplink, but for purposes of this talk, let's just consider an uplink as somebody who wants to use our service to store information on our network, and they do it through that utility. Now, I'm sure the first question I asked when I joined was, that's crazy, you're going to store my data on somebody else's computer and just hope for the best? Like, okay, best scenario, they lose it, and I'm angry they lost it. Worst case scenario, they steal it and they use it for something malicious. Right now they have all my cat photos or something of that nature. That's, how are you going to get around that? Well, the satellite you see here, or the satellites, I should say. By the way, I'm known for my corny metaphors, so bear with me, but it's who I am. If you think about the quarterback of a football team or American football team, they are, for most plays or for most instances on the field, the ones that are coordinating the effort. They get information from a coach, but ultimately they're responsible for figuring out what to do. I'm going to give the ball to this person, or no, I'm going to give the ball to this person. Using that terrible metaphor, our satellites are responsible for controlling the metadata for the information that our customers and clients put onto our network. So, if you upload a file, by the way, like speaking of internet, did that make sense? Because if it didn't, yeah, okay. So again, this is just very straightforward, high level, like steps 1 through 8. But this is how we deal with those concerns that theoretical, not theoretical, past Patrick, but 3 years ago, was asking about. Yeah, that's very decentralized, but how do you protect against all of these different attacks, malicious or otherwise? So, what we do is, we are very, very careful about choosing nodes. Talking about like a quarterback. One of the main responsibilities, to call it that, of a satellite is to be aware of nodes on this network and to choose ones that we think are trustworthy. So again, that is not cryptography, trustworthy people who become untrustworthy, but nonetheless, it all starts with developing and maintaining a node population of people or individuals or groups or whoever that want to be there and are there for good faith. But that's not enough, right? I would never use a product just on that level. Like, oh, I trust a person, they signed a contract. But, no, I don't think so. Not just that, a lot of people sign contracts to use it. But nonetheless. So what we do is we use a lot of really cool math for erasure encoding and encryption. Well, at high level, the two things that you would be worried about, that I mentioned, are losing information and somebody corrupting it or stealing it. Well, and I'm not a cryptography expert, so if you have questions about how the cryptography actually works, I'm more than happy to direct you to people I know that do. So for me, we do some really awesome cryptography, and people I know that I trust tell me it's really, really secure. Something that I have more expertise on is something that actually we'll get into a little bit here on the erasure encoding. Are you all familiar with erasure encoding is? So erasure encoding, yeah, when I say high level, a lot in this talk, so if you've ever done this, somebody just tell me to stop. But if you have a set of information and you put it somewhere, it's like, well, you could lose it if that one single thing, somebody took it, like took my bag and left it. Well, if I was able to duplicate my bag twice, well, I would have two bags now. So if one went away, well, I have another one and I'm happy. It's pure replication. I'm just taking information and I'm just repeating it over and over again. But yeah, sure, you repeat it a billion times and you have a billion things and do statistics and say what's likely to be going away completely. But that might be a little inefficient. So one purpose you can use erasure encoding for, back in the day, we don't know about this, but error correcting code. So taking information that's lossy and being able to correct that to its original state. So if you think about it on our network, we take a file and we break it up into a bunch of pieces, erasure shares. And then what we do is, using some cool math that afterwards more than happy to talk about if anyone's interested, and create more shares, or parity shares. And what you end up having is a bunch of blocks, or shards, or we call them segments and pieces, on our network where each individual piece goes to a different node. So if one node decides to have a bad day, or they're using Comcast, and sorry if anybody lives to Comcast, and their internet goes out, well, the person who put their file on our network isn't out of luck. Right? There are ways of recovering that information to sort of that client user or the customer. It's completely seamless. They got their file back and they're happy. They don't have to worry about that. Another thing that you would want to do to maintain this system effectively and cost efficiently, because right now what we've been talking about is kind of just like the brass tacks of we need to keep it there, we need to keep it secure. But if you're us, aka Storage Labs, well, I just made a very bold claim earlier about Amazon's awesome and they're the pinnacle, but you can do it better, right? And in this sense, that means economically more efficiently. So if you're just constantly waiting for all the data to disappear and then you're going to repopulate it, well, I'm sure you know, time and space, there's always a cost of something. So doing erasure codes are awesome, but it costs something to use them, to rebuild that information. So we're constantly auditing our nodes and making sure, like, hey, are you there? Okay, if you're there, do you have a piece of data? Right? Use like statistical tests, we'll randomly select a piece of information and say, do you have this one? Do you have it? Okay, awesome. If we use I won't go into it, but some interpolation techniques to say if we can reconstruct something, then it's there, and when we go out, it's statistically random, but you can degree of accuracy say that person is worthy. What we call a reputation. So we have a reputation scheme. All of that combined means that you should be doing repair less frequently if you're choosing nodes correctly, more efficiently if you're choosing nodes. You know, there's a whole branch of optimization theory about the way to allocate resources efficiently and all that fun stuff, which is very interesting and is very much a part of our network. But to bring it all back together, like that's what the satellite is doing. Again, the satellite does not have keys. That all stays client side. It doesn't have an ability to look into somebody's picture and say, oh, let's see what Christmas Eve from 3 years ago. Wasn't that funny? But it does have what we call pointer information. Pointers point to locations on our network. So an uplink goes to retrieve the file. It says, hello, satellite, I would like my file. Tell me where to get that. Sure. Takes all its inventory, so to speak, of all the different pointers, and oh, they're here, here, here. Go get them. Right? And then the uplink speaks directly to these nodes. That's where you see like the stream of parallel, and then breaks it down and well, have the client side. Does that make sense? I know it's well, a lot of stuff that I glossed over.
Patrick?
Yep.
Except it's not really a satellite up there.
No, sorry. Yeah. that would be cool. No, these are servers. Oh, I'm sure if we talk to anyone else, I can figure something out. That's the network. What I teed up earlier was, okay, we're developing this thing. We went to V3. We have a certain amount of time to do this. And the business need here is the business need for an analytic system. Why we're talking about this and why we do it. It wasn't just because, hey, this is going to be fun. Sometimes we do that. And that one, the future of our organization is dependent on it. If you see, like, this is our V3 roadmap when we felt confident of, like, we had an alpha product to, and don't take these numbers as sacrosanct because obviously it's already Q1 2020, but given some margin, these are pretty accurate, of how we teed up last year of progress on product. We wanted to go from alpha to production fairly aggressive timeline for what we were trying to build. Well, like I said, we start out with a white paper. So here's something interesting. If you want, I should have said this earlier, but questions. Anybody who is interested in getting into kind of the nitty-gritty internals of the cryptography, the erasure coding, the optimization things, the statistical techniques we use, it's all in this very, very light reading 95-page white paper with a bunch of, I like it because it has a bunch of really cool math that we put together, but it has a really, really interesting in-depth description of what we set out to build. For context, like we started there, but when you start with, I know this for a fact, right, like as a data scientist models, when you just do applied math, it's like, this should probably work. Well, sometimes it works that way, but you know, assumptions are faulty, right? We're assumptions to the human condition. So this is a lot of probably words, people, but I put this here just as one kind of just simple, not simple, but just an example of the type of dynamics and relationships that we're modeling. I'm sure we can share these slides afterwards. Like, just read this. You'll see we have things like mean time to failure. So the rate at which nodes go off the network is going to affect what we were talking about earlier about losing data. A node leaves, well, you also know those pieces. If it increases, well, you're going to lose faster. And it affects other things. So now I'll that. I think, and this is the mathematician nerd coming out of me. If anybody's ever studied kind of population dynamics or systems of differential equations, where even simple things like, there's a famous one called predator-prey model. You have, I think it was the fox and a rabbit, yeah. And they just follow the populations of foxes and rabbits. And it seems like, oh, that's pretty simple. Foxes eat the rabbits, rabbits eat more rabbits, but little changes can make really, really crazy results like down the line that this is a human being using your brain to be able to predict. Oh, we have, well, it's not predator-prey, but a similar situation where theoretically, like, we think it should work this way. But we can't wait an entire year and say, yes, we have a product that we're going to production, and then run some tests and go, oh crap, no, it doesn't work that way. That would be bad. Well, I mean, like I said here, honestly, I would love to, anybody's interested to come back and talk about these things in depth, because I'm a giant math nerd, talking about it. But we use assumptions to tune these parameters based on previous experience. Our VP of engineering, JT Olio, has worked on other distributed systems before in various places, so he has a lot of very excellent insight into it. So, okay, well, given this, it works this way. Well, we're building a brand new thing. We need to, before we're going to progress any further, confirm that it works that way and modify it. Secondary/tertiary reasons. We take it very seriously around when we say that we are in alpha and move into beta and we're moving from beta into production. By the way, take it seriously. And I have a link here to a blog post our CEO Ben Gold wrote on what we call qualification meetings, what's the key metrics that we use as determinations of, are we ready? Are we willing to go look somebody in the face and say, pay us money to store your information, and with full faith and confidence, say yes? Because you don't really get a second chance when you tell somebody you're going to store their information and you can trust them, and then you lose it. Like, nobody's ever going to use you. It's just game over. And we are not only very cognizant of that, but we know that if we don't have these metrics and not hitting certain rates, like durability would be a metric. Right? But if you lost a file, if we have, then we have to go back and figure out if we have it, by the way, but which is in that blog post. But if we had, we would have to figure out exactly why, and until we nailed that down, we could never go talk to a customer. Right? So again, the theme here is we need something to start producing information about these things now, as opposed to later. Because, well, if you can't measure it, you can't improve it. And another cliche is you're driving blind. And if you're driving blind, you go off the cliff. And then also, which to me is equally important from an internal aspect, internally to Storage Labs, it's not all just engineers, right? We have wonderful people like Jocelyn on the community. We have people in marketing and PR, sales, who are trying to do their job, and their job is easier and they'll be more successful with quality data. To go talk to somebody on a sales meeting, and like that idea of have you lost a file? Well, it's much easier if you're somebody trying to convey a message to a potential client and say, nope, we haven't. Let me show you exactly why I know that, and go into it, versus, I'm pretty sure we haven't. Right? One's a little bit more convincing than the other. That's important. We're going to have a commercial quality piece of software. You have to have no ambiguities. So that kind of again, tees up why this is so important and why some of maybe the things we're about to go through make a little bit more sense of, okay, so you kind of just strip down the car. Oh, actually, before I get ahead of myself, for me, I'm a giant gamer. I love this. I'm one of those very lucky people who love what they do for a living. As nerdy as it is, like designing data systems and thinking about how things interact and models, and I love it. I would not lie otherwise. So when this project came up, let's build an analytics platform. Hell yeah, I've done this before. And I swear this actually is what I probably looked like at the time. Okay, we're gonna get all the data. We're gonna get NASA satellite projections of alpha. Somehow that's cosmic rays. Yeah. And I found this while putting together my notes for this presentation, and I felt remiss if I didn't include it. So much possibility. No, not to speak ill of this. It's actually, again, really interesting, and if you have any experience dealing with case systems, I'm pretty sure you could find everything you've ever used in here somewhere. We have Flink. I don't really know what Flink was supposed to be used for, because I still can't find a reason why we would need it. But nonetheless, and also I have here, coincidentally, this is also what we got a new Jamboard, but this is not my art, by the way. This was somebody else. Much better artist. I'm terrible at that. But this was the grand vision. Yeah, we're gonna do all these things. And that's great, that's fantastic. I'm sure if we had about 5 years and 100 more people devoted to it, we would have done a lot of really cool stuff. But, well, sadly, that's not how it works. And it's not only about people, resources, we have to go hire people. That doesn't really fit in necessarily to kind of our ethos as what we're producing. Something I haven't really mentioned the topic of this, but we are an open source free software company. We build things for other people to use that aren't necessarily the Storage Labs entity. We have, I should have brought it up earlier in the slide, something called Tardigrade, which is our brand of approval. This is ours, but anybody can take this and run their own side of it and have their own nodes and set up their own, what was it, Mastodon, or totally messed it up. But communities who want to share information with themselves can set this up and do that. So if we have a telemetry system or a metric system, which Polygon use too to monitor their own system, that involves 400 different pieces of analytics software, some of which I don't think exist yet. that's not great. That's saying something to our community people behind us that it's a bifurcation, and that's important. Also, it has to be flexible. All of those different, again, every single one of these intersections and nodes is a different point that needs to monitor itself, and it's like, turtles all the way down. And again, roadmap is a year. Right? All this done. It's awesome. I love it, but well. I'm saying this because he hates when I give him praise, but JT and I, the anonymous VP of Engineering, talks, and because he's great at what he does and has a ton of experience, like, I have some ideas on what we can do. And Dan President, have you ever heard of him? He's like, no, I haven't. And to give you, before I move on, a little bit more history about my came from crazy experience. Up until I joined Storage, the companies I was working with and the projects I was building, well, yeah, I talk about complexities of machine learning and everything, but in terms of the architectural pattern was very classic. I have a database, I have a front end, I have a back end that does stuff, and stuff goes into the database, and it goes out, and cool. I'm a data scientist, I'm just giving the database and I'll get on my way. Well, that doesn't, like, we have nodes, 99% of the software and hardware that runs on our network, not only do we not own, we can't just go connect to 3,000 different databases, 30,000 different databases. And, just off the top of my head, I know that will never work. Right? So you need something that, instead of changing the paradigm, which was, for me, a great learning lesson. Stop trying to fit like this decentralized thing into what you're used to. Let's think about other possibilities. And this is where, and hopefully this is not new to somebody because again, like a learning opportunity to talk about different versions of using this. Because this is the first time I've used this kind of paradigm. And Monk.it is. Put these in order so it's not like this. Instead of having a database that your back end or front end services go to, what you have is, well, let me take a step back. Monk.it is what it says. It's very simple, lightweight metering, counting, captures event data. The thing happened, and I want to understand it, so I'm going to count it. So what you see here is this comes from what we call our checker service. So I was talking about earlier about like auditing and checking and making sure that things are still there. Well, what we have here are Monk.it events, pieces of data, and each of these is a different time series that are right in the code base, right? So you build the binary and you install it, you run it, and this is there. So no matter where you're doing this from, whether it be on Mars, satellite, or from right here in San Francisco, that's running on your machine and it's getting sent to some location. And that location is configurable as a config file. So here's the address. And this port is just UDP packet. So it's like bullets, right? If they drop, it's fine. So with that context, this was JG's idea. And there's something a little bit different between this and this, right? Michelangelo looks like could have produced this, and well, I did this on my laptop, airplane from plants. But this is the more powerful pattern, and this is what we went with. So what we have here is, and this was my attempt to demonstrate that it's not Monk.it code, it's the Monk.it software. Is in all of, right, like it's in our uplink software, it's in our storage node software, it's in our satellites, and it's running wherever our software is. And it's collecting all this really interesting telemetry information. What we do is, like I was saying earlier, via a config, which is talking about the point earlier about making sure that other people who are running or not stored entities can use this to benefit. It's configurable. So if you want to send it to your own and you want to build out the grand vision, go for it. You're more than welcome to do that. Probably actually the web platform. But what we have is what we call stat receiver. Terrible names. It's receiving statistics. All of those UDP packets from Monk.it are being sent into it. Just sits there, and it does for to analytics, basic process like that. Serializes it, cleans it, or removes anything that might look wonky, and that's it. Now you could change that if you wanted to, but that's at the time when we first started this, that's all we needed. And it sends it out to to the configuration, but to wherever you want it to go. But what we chose was InfluxDB. So what it does is it sends Graphite Protocol time series. Are y'all familiar with that at all? So it sends it via Graphite Protocol directly to Influx. Let me go. And this is hard to read. This is a Lua file, and I'm seeing a learning opportunity. I had no idea what Lua was before we started this project, and now I do. It's interesting, but what we have is a configuration system that is written in Lua, and what you'll see here is you filter things out. So what this is saying is, I want the telemetry information that's coming from storage nodes in our dev or production environments, and I want to know the space that's used available. I want to know those things from all of these different nodes. And to me, as simple as this might look, it's extremely powerful because the dynamics of our network is we need to know at any given time if we have enough space to accept new information, right? We don't own the hardware. We can't go out to, well, I was going to say Best Buy, but I don't know if that's still a business. But insert big box company here and buy new hardware. We have to be very on top of being in front of the curve on things like if we're going to run space. That's one of thousands of different things. But it's all being, well, not the prediction, but just the management of it is through a little bit. I know I keep on coming back to this, it's like this is a miracle, but it's, to me, this was really, really interesting. So I never really had thought about this, doing it this way. And Influx, I swear, I thought this before I knew I was coming here, is really, really cool because it supports the Graphite protocol that the stat receiver natively supports. And just for some context, the reason that stat receiver is Graphite because the person who wrote it, I can't remember their name, so forgive me. Like what they intended was like they wanted to use Graphite. That's how we started for first system. Graphite is fine. It's useful actually. I think you might use it for some things. And again, under time constraints, it's okay. Are we going to rewrite this to speak Influx natively, or are we just going to go with Graphite? But amazingly, after looking through the documentation, which, like no joke, it was a very happy day, as corny as that sounds. Influx has a pretty cool templating feature that, and by templating I mean it takes the, and somebody correct me if I'm totally doing this wrong, but it takes the Graphite protocol time series, and you can essentially using regular expressions and I forgot if that's the term, break it up and create kind of your own data model. So instead of just thousands and thousands of, well, you still have thousands of time series, but you can bring structure and taxonomy to it. So I don't have the names here, so I can't help but one template could be taking, like I showed earlier in that config, all of the different node information. So I want like all the time series related to disk space or CPU usage. That all exists in one measurement. And again, I don't know if this is technically true, but I like to think of measurements as kind of a table inside of a relational database. So I know that if I'm on the node disk measurement, well, this is where I can go find this stuff. And for somebody like myself or a team or anybody who's trying to find stuff, having order to the chaos is super important. So this was kind of the first, holy shit, it looks pretty cool. So, well, again, to go back to it, we have OneKit collecting all of this telemetry information out in the wild, directing it to a random, a server we have set up called Stat Receiver that's doing processing, filtering, all that good stuff. And then from there, well, you could send it to anywhere. It's like the Lua config file, if you want that, just send it to a dev null if you wanted to. But we have it go into Influx, and we've created taxonomy. Use that word, of all of the different, not all, but some of them, but all the important metrics that we need to do our analytics. So we get a bead on what's going on. real icing on the cake, which was, okay, we were going to use this because we can get it really fast. If you know SQL, you can learn to use query influx like probably in a day effectively. I'm not even joking. I mean, it's SQL, right? But on time series database that has a very, very different structure from relational databases. And when I saw this, I was testing it and playing around with it. Holy crap, that's awesome. No longer do I have to worry about if we're using, and there's all like pros and cons. I'm not saying this to as far as any of the type of software, because they all are great in their own way. But if you're in our position where you have our CEO and others saying, I want a dashboard showing you this, this, and this, well, I would like to just be able to go to my comfort zone, write some SQL, and show them things immediately, and not have to worry about learning a whole new query language. Again, there's something wrong with that. Like, I know how to query MongoDB. Maybe that's the reason why this made me so happy. But this was really cool. So, really, as underwhelming as it may seem, this was it. This was our MVP. We, again, with many people's help, which JT, our entire engineering team, and many others, figured this out. It's like, all right, let's build this. Did it. And the question is, it's like, okay, cool. So I just showed you, is like, hey, this very hyper-complex system of Apache Flink, Hadoop, Cassandra, buzzwords here, and you just stripped everything away. You just made simple ETL and a pipeline. Like, that's great, cool. You made it really efficient. But is it useful? Is it actually, like, did you need the other thing anyway? No. So what I didn't mention is we put this on top of. There's a BI tool called Redash. It's an open source tool. I don't know if anybody else is familiar with it. I wasn't until we started this project. It's pretty awesome because it's open source and people are like, this doesn't exist. I'll put a PR and then it'll exist. It accepts incoming connections and data connections from all different types of databases. So we have it's connected to a Postgres instance that we use for our data warehouse. It's like on the marketing product side, like Growth Metrics, Google Analytics. And that lives side by side with some, in my opinion, hardcore telemetry time series information, and you can put that story together. And that was pretty cool. But we just from this simple, again, conceptually simple, straightforward pipeline, and I call this the state of the network once the name is stuck, started giving not just me, others as well, the state of the network address of data-driven guidance. Every week, going through all of the different metrics that we're collecting, the dashboards, different models that we're measuring, making sure that we're tracking on target, and talking about, well, root cause analysis. I'll put this here because I'll never forget that. I was still on my chair one day, and just boom, half the network just decided they didn't want to be part of it. And I was like, what? All I'll say is that had something to do with Kubernetes. Kubernetes to me is still black magic, and I have no idea what I'm talking about. So I'll just say it was a weird DNS Kubernetes thing. And well, when DNS is involved, well, people can't contact you. It looks like they went away. But again, this simple stack was able to pinpoint. It's like, boom, okay, that's a problem. Let's take care of that. And Redash has other things in the stack have like alerting features. So hey, computer, when half the network goes away, please tell me. Right? Send me an email. Page me. And then less of like kind of a holy shit moment to keep the lights on sort of thing. But talking about tracking, so our goals and tracking to models that we built or just expectations of what we set for ourselves for our network performance. What you see here is, and this looks confusing and messy because of the thickness of this, but if you think about the distribution, I was talking about earlier about erasure. Take a file, we can break it up into certain pieces. What we want to do is, or what we want to do is, over time, for the population of file, see what's the attrition for each of them. So how many have 50 left out of 80? Right now we use 80, 20 times. And it's a whole separate talk, but I'd love to go do something lazy with pair. So if you have to start at 80, and you need 29 to reconstruct it, there's some value in the middle there that's optimal for when you actually want to trigger the pair. Because if you did it immediately, you spend a lot of money doing it. But if you wait too late, well, then you're playing with fire because you might lose the file. What this is that distribution. Think about like percentiles, which is the query issue. This. Over time, this line here if you ever start seeing that, or see how this is flat, if you ever see that start going sloping downwards, well, that's a bad thing. Something else is going on with that. Our attrition rate is way higher than usual. So this, I mean, again, this is really useful, and this is going fast. Now, like, I love giving those talks, and fantastic, a lot of positive feedback about this. But what's also really cool about this, and I'll be honest, because for sensitivity about data, this is somewhat nonsense. So hopefully the message itself is conveyed. But in real time, looking at our model parameters, or specifically, I didn't draw it here, but if you think about bytes on the network versus how much repair you're doing, there's some optimal ratio that you want to hit. So we have, say it out loud right now, but a number that we're looking for that tells us that we're on track. Well, right now we have dashboards live that are looking at that. So whether you be a data scientist, somebody in engineering, somebody in sales, whoever, and you want to see, hey, are we building the thing that we set out to? You can come here and look at it. And it's real time. It's as real time as the data that's getting produced. So really, really cool things. It's kind of, I know I start to sound like evangelical, but very eye-opening with the power of what you can do with a little, with some relatively simple tools.
Excuse me. So, what is the model here?
I'm sorry, I can't hear you.
What is the model here?
Yeah, that's a good question.
Can you repeat that?
What's the model here?
What's the model?
I could go into the details. It's in the white paper, but essentially, you have a certain amount of information on our network. You have a population of nodes that, at the limit, which is the most mathematics term ever, like just this cow is spherical, but at the limit, there's some background noise. There's some, like, people are going to join and leave at some rate, so there's a natural attrition rate. And that natural attrition rate is going to cause a certain amount of repair. That's just the cost of doing business, so to speak. If you're, look at the data, do some models and say, okay, given what we see, this is what we expect, and then you go build some financial models or expectations for sales and all different things. Based on that percentage, well, you need to know if that's wrong. Right? There's a term that sounds fancy, but it's not, like heteroscedasticity. It's the variance changing over time. Again, it's a relatively new system. 5 months of data or 4 months of data might not be enough to say this is going to hold into the future. So this is what that's looking at. So if you see here, and again, this is fudge, but time series of the amount of repair we're using for different satellites. And again, like I was saying earlier, it's not just one satellite, many satellites. People can run them. One of them, our place, Stefan, he has his own satellite, which is pretty cool. But did that answer your question?
So yes, so you try to model some system. So how exactly do you use this model for? Do you do some predictions, forecasting?
This one, and I can't, I sound like I'm hedging a lot, but some of this, I didn't get permission to talk about, so I'm just going to assume I can't talk about it. But yes, like some of these things go into things like financial models, and, so forecasting, right? Like if you're forecasting a certain amount of information on your network, well, if you have a certain pricing scheme, that's going to generate a certain amount of revenue. Repair costs money, margin will run. So yeah, that's my talk. And here's my ask. Future roadmap. I was speaking something earlier about the full tech stack. As I don't think I made this clear. What I just went over was like the MVP. So that was 6-7 months ago. So we've been building it out. We have, if I had more time, we would go into it. But as we play around with different systems and different ways of doing analysis, well, I spent a lot of time like looking at not just the Influx database itself, but also chronograph, capacitor, and all the different things that look into it. And it seemed interesting. So there's a question mark. So if anybody, I'll be over there. If anyone wants to talk to me about it, I would love to pick your brain. kind of that's sort of related to your question. That, again, the simplicity of it as well. Right now, the statistical modeling piece is me grabbing that data, writing some scripts, figuring it out, and then putting it back up, and automating that. That's how I build this. So where I don't have to bring my laptop around anytime somebody wants to figure out what the optimal ratio for repair is. And this last bullet, this is very much a longer term initiative, but kind of what I spoke about earlier about fitting the paradigm for what you built. While this is different from the monolith that we draw on the Jamboard, but it still is centralized, right? Like this is still shows like this is a centralized pipeline going from step to step to step. It would be really cool and interesting if you could figure out a way to do that in some type of decentralized nature. One example would be, well, not an example, but one of the people on our team, his name is Dr. Benjamin Serb, we call him Dr. Ben. Some of his work focused on having, on a volcano, different nodes, figuring out how to do seismographs and kind of create different pictures, but all with like really cheap nodes you can literally throw into a volcano, right? And then still produce some useful information. But a lot of the algorithms you have to do that type of work don't really exist yet for distributed type networks. So doing research into that and figuring out if we can centralize. So yeah, that's my talk. Hope it was interesting, or at least I didn't bore you to death. More than willing to take questions and talk.
So I'm just curious, how do you plan to monetize the whole thing on here? And also, I'm a little bit confused about this again. You try to sell storage, cloud storage, or try to sell this long kit, or this kind of statistical time series model?
Sorry, sorry to make that clear. This is our internal stack that we use to do analytics. Monkit is it's on GitHub if anybody can use it. But this is not our service. This is not what we sell. This is us using it to make what we sell better. Yep.
So you're a storage company, cloud storage.
Yes. Yes.
And how do you monetize it?
I'm not the person to. Yeah. Oh, sorry. The question was, how do you monetize what I just went over? And I'm not the person to answer that question. No, I mean, and I'm not saying that because I don't really know the specifics, and anything I say will probably be wrong. I don't want to give the wrong impression. Oh, yes.
I have two questions. Is storage one or two syllables? And who uses, like, why should someone use storage as opposed to AWS?
So the question was, is storage two syllables? Yes, I have a really bad habit of my brain looking at the word and saying storage, so sorry. Yeah, and the second question was, if I understood correctly, like, why should somebody use this? It's a good question. The main selling point, or I don't want to say selling point, but high points are, to me, two things. One, security. All of this, again, cryptography that I don't have a general understanding but not in-depth understanding of. From top to bottom, everything's cryptography by design. Right? You have to use it as opposed to an optional thing. It's like it's cryptographically secure. And there is a subset of human beings where that's very important. Again, especially given the past couple of years of losing data, whether it's fear-driven or not, nonetheless, people, that's important for them. Also, pricing, lower pricing. If you figure out a way to make this cheaper than other folks, well, supply to that.
In terms of the time series volume you're collecting, if you're allowed to disclose that.
The question was, what's the time series volume?
Volume, yeah. Is it billions of data points a day? How many data points a day are you at scale will this thing be collected?
I'll tell you this. So when we first put this in motion or set this up and running for the first time, which was 7 months ago, I think it was like 7,000 a second. So whatever that multiplies out to be.
Sure.
Right now, it's significantly higher.
Okay. Thank you.
So, as far as I understand, like you actually deal with the big time series data with influence, right? But have you ever had any chance to observe the forecast versus the actual values? I mean, have you ever tried models that you see the forecast actually fits really, really good on the forecasting, like estimating the actual values with this influx? How was like its accuracy and some models performance? I would love to like.
So-
if you have any experience.
So if I understand the question correctly, it's do we use Influx itself to do any of the modeling and forecasting?
Yeah, I mean, I would love. I mean, I was expecting to see like you actually use like the forecasting, and I would love to see like some the like forecast versus the actual values, which is really good, gives us a really good results. Because I cannot understand like even you use, but am I got a really correct result? Like it's really worth to use this influx because it's really estimates and forecast values being like the actual values, or so it's like only to use like a manage the big time series data. So I'm just confused. Like should I use like a managing the big data time series data? Should I use like the modeling to forecasting for actual values?
I'll start with, should you, like, it's very specific to whatever your paradigm is, right? Like there's no one fit solution. Or what's that phrase? If you have a hammer, everything looks like a nail. What we are using Influx for, which because that was the crux of the issue, is handling the information, formatting it, putting it into a usable, like taxonomy, so we can do other things with it. We don't use it as like our forecasting engine, if I understood correctly.
It's not meant to be a forecasting engine.
Yeah.
So what type of statistical models do you use for your? What kind of statistical models do you use?
The question was what kind of statistical models to use. That's a very expansive question. Some here off the top of my head, talking about auditing. So remember, like auditing is statistically going out and talking to a node and saying, "Hi, you should have this piece or this piece of information. Please provide it within this time span. If you don't, well, that's a problem." And you and I could like talk about it in details because off the top of my head, I'm probably going to get terribly wrong. But just Bayesian inference models, it's going over like, hey, put your prior, and at the beginning, like, prior was literally flipping a coin because we don't have any previous information to look at what the baseline behavior of nodes are, and it's also affected by economics and all sorts of interesting things. And we use something called a beta reputation. I don't know if you're familiar with that, but you have certain decay weights of simplification. There's something that happened 10 years ago had the same effect as something that happened yesterday. Right? For some things, yeah, probably. If I kill somebody in cold blood, maybe yeah, I'm still going to be concerned about it. But if I forgot to lock the front door, that's okay. So that's the type of statistical model that we use to determine what we call reputations. And if a reputation goes below a certain critical threshold, we no longer work with this node because, again, it incurs, one, that you might lose information or be malicious, but also even if it's not your fault, it's just circumstance, well, you're incurring extra costs to our network that we're not able to take care of. And I mean, like I could literally talk for another hour about all the different things. So, I mean, yeah.
I have two questions. The first one is that when you're going back to the qualification gates, the metric, each problem will have different metric to solve. And how flexible is the ETL pipeline to all of these metrics if you want to change metrics for each of your business cases? And the second question is that are you using a third-party server to store the hash rates that you generate from your decentralized network?
So the first, second question, because I forgot completely. The question was, are we using a third-party service to store the hashes from our keys?
Yes.
I don't know the answer to that question, to be honest. That's not my expertise. And what was the first question again? I didn't.
The first question is that how flexible, because each problem will have different metrics that you want to optimize. So how flexible is the ETL pipeline to each of those? Like, I'm just asking on the sensitivity. How easy it is to change them for your business cases.
Relatively easy. And, well, depends what you mean by easy. There's easy and time-consuming. There's easy and but flexible, but very complexity. So I think, to be fair to ourselves and to you as an audience, I would say right now we have easy, but slightly time consuming. Because if you notice throughout all those different configs that I was talking about, you have to go in and say, okay, I want to filter this here now. Okay, now I have to build a template here. So if you filter something out, well, now you might have to go change that template. Conceptually, it's straightforward. Like you have to do this, this, but yeah, it takes a little bit of time. But that is, especially then, something that we were willing to live with because we were producing usable information, and that was far outstripped by the gain we got from things.
Talking about the template, I'm wondering that, I know this is some sort of like a timing effort. You're using like 3 different templates in your diagram, right?
Yeah, that was
Probably
just
a few more, right? It's just diagram.
Yeah,
But it
that's-
seems to me like you're using template to send different bucket of data to I mean, that's I think normally, most people would consider using some sort of AI or deep learning or machine learning instead of slot feeding. You cannot predict what kind of event is going to happen. The template sometimes can affect it.
Yeah, but yeah, for this, I see what you're saying. Is people do use it that deep learning for this would be way overkill. The long-term solution is actually rewriting the stat receiver to deconstruct and construct it there, as opposed to using templates. But again, the context with this is always that we needed to build something fast, and so it's just.
Awesome. Thank you so much, Patrick. That's really awesome. It's always great to see different ways that people use InfluxDB. I love seeing that people use filtering the data before putting it into InfluxDB. Maybe later on we can even talk about how you can use Telegraph to do some of the analysis at the edge. There's lots of different ways that you can definitely use the tick stack. I apologize about the heat. This is our first time doing this little room. We'll figure it out next time. But stick around, ask questions. If you really need to leave and you want to send an email to Patrick, just email me on Meetup, and then we can definitely get you guys connected. So thank you so much.